Exercise 9B, the 68, 95 and 99.7 rule. Okay, so that's three percentages. It's 68. This didn't print very nicely in the title. Oh, sorry. So it's 68%, 95%, and 99.7% rule. And those three percentages are very significant. We'll talk about that in a moment. And that information is on your formula sheet. So you don't actually have to remember the percentages themselves, but you will definitely be using them. Okay, so a normal distribution, we looked at normally distributed data last lesson. So a normal distribution has the same mean, mode, and median. It is symmetrical about the mean. So the left-hand side looks like the right-hand side. The percentage of data that lies within a certain number of standard deviations, or z-scores, is always the same for a normal distribution. Okay, so if we have a look down, we spoke last lesson about how normally distributed data, when graphed, will come out and give us a bit of a bell curve. Okay, it's symmetrical, highest point in the middle. Now, the significant percentages that we just mentioned, 68%, 95%, and 99.7%, represent the different parts of that bell curve. Okay, so I don't actually love how they draw it here, so I'm just going to redraw it as I explain it, because I think that'll be easier. Okay, so there's your mean. Imagine that I can actually draw symmetrical. Oh, it's not very good at all. Let me do it again. And you will need to draw these bell curves when you do the questions, so good luck. They never come out like that you want them to. Okay, so let's just pretend that's perfect. Alright, so basically what the rule tells me is that within the first standard deviation, second standard deviation, and third standard deviation, a certain number of the data will come up in that section. So for example here, that's that middle bit. That obviously is a large number in there. That there represents 68% of our data within one standard deviation of the mean. Okay? Obviously that means that each of these portions is half of 68, so this is 34%, this is 34%, and that's helpful to be able to find because you will need that to work with some of the questions. Now from 2, so this is minus 1, minus 2, minus 3, 1, 2, 3, okay? From 2 standard deviations, so from here, all of this, and that still includes that middle section. I just won't cover over it. That there represents 95% of the data. So the 68% plus the overflow. Okay, so that's that there. Okay. I didn't draw that very nicely. So that's this bit to this bit. Okay. The remainder, the little bits at the end. So 99.7% of all the data for normally distributed data will be within 3 standard deviations. Okay, so obviously down the ends here, you'll be like, well, what's down there? There's obviously a bit of overflow, a bit of data that falls out. Okay, so very small amount. Alright, so we calculated that those two green bits were 34%. It's also important to note that 50, because this is the median and the mean, 50% of my data is on this side. That's 50%. And this here is 50%. Okay, so if I pull this apart even further, let's say I want to know what's in here. I know that it's going to be 95% divided by 2. So that'll be 47.5% minus 34. Okay, because 47.5% would include all of this. Okay, so what is that? 13.5% is in here. Okay, same goes down here. 99.7. Should have really brought a calculator with me. 99.7% of the data, taking away half of 95, which is 47.5. I'm definitely going to find a calculator for that one. Just give me a second, sorry. So 99.7, half of that, minus 47.5. It's a really small amount in there. So that will be 2.35% of the data. Now, let's check if I'm right. So that plus 13.5 plus 34 should equal 50%. I'm off 50.15. What have I done? 95 divided by 2 minus 34, 13.5. What did I say? I did say that. 13.5 plus 34. Oh yeah, it's not going to equal 50. What am I saying? Because I've still got the overflow. Okay, so that is right. 47.5. Take away that. Yep, okay. So I said 2.35% in there. So sometimes that will help as well, but you have to calculate it each time. Okay, but the whole point of this is that 68% is within the first standard deviation, 95% is within 2 standard deviations, and 99.7% is within 3. So not all the data, just 99.7%. Half of your data is on one side of the mean, the other half is on the other side. Okay. And that's rewritten there for you. Alright, let's have a look. So, a normal distribution of scores has a mean of 75 and a standard deviation of 5. Complete the information about these percentages of the scores. Alright, so draw a bell curve. Whenever you get any normal distribution question, I will tell you this over and over again. You have to draw the bell. It makes it so much easier. I personally can't do them without the bell. Okay? So I'm going to draw my 2 standard deviations, and it's obviously meant to be symmetrical, which kind of is. Alright, so that's 1 standard deviation, that's 1, 2, 2 minus, and that's 3 standard deviations. Okay, so the mean here is 75, I'll do that in red, significant information. The standard deviation is 5, so that means that 75 plus 5 is 80. 85 and 90. Okay, so everything up to the score of 80. This is 70, 65 and 60. Okay. Okay, 50% of scores lie above 75. Okay, so we know that 50% of scores are over on this side. Let's see if I can colour that. Okay, that's 50% of my data should come up in that section there. Okay, so that lies above 75. 68%, so we already know that 68% is here to there. That's all of that. And that goes between 70 and 80. 95% is, let's do it in blue, is from here to here. And that's from 65 to 85. And then 99.7%, that's what's left, purple, from here all the way to there. So it's not 100% of the data because we've got the little bits that run off. That's between 60 and 90. So you can score between 60 and 90, but there wouldn't be very much in that range if it's normally distributed. Remember, all data doesn't have to be normally distributed. Alright, so that's that one. Next one. In a normal distribution, the mean recovery time after contracting a certain disease is 12 days with a standard deviation of 2 days. So let's draw that straight away. Bell curve, probably a bit big. I still need to write the answers. Okay? And there's my mean. Okay, so always mark your mean. So my mean here is 12 days. Okay, so we're going to have 1, 2, 3. Okay, and there's a standard deviation of 2 days. So that's 14, 16, 18, 10, 8, and 6. Okay. And I always like to draw my sections. Okay, and trust me, you don't want to really do these questions without a drawing. It's pretty hard. Okay, so how long would it take for half of the patients to recover? So half would be anything up to the, or half of the data, so 50%. So how long will that take? 12 days. Okay. What percentage of patients would recover within 8 to 16 days? So 8 to 16, that's from here to there. Okay, so B is that one. And that would be, that's 2 standard deviations, so 95%. C, what percentage of patients would recover within 10 days? So within 10 days, we're looking at this. Okay, so we've got to find that section there. So what we can do is we know that the whole thing is okay, so we know that the whole half is 50%. And we've got to count what's out here as well for this one. That includes that. So if we know that half is 54%, and we before worked out that this was 34, because half of 68, that section will be 50% minus 34%, which is 16%. Okay, D. If 400 patients contracted the disease last year, how many recovered within 16 days? Okay, so we know that that's going to be 50%. Okay, sorry, I should colour it so you know what I'm talking about. That was green. Let's do maybe yellow. So within 16 days is all of this up to here. All of that. Okay, so I know that on this left side, this is 50%. And this here will be 95% divided by 2. Okay, so 50 plus 95 over 2. So that equals 97.5%. But it wants to know how many recovered. So it's 97.5% of 400. So 97.5% times 400. Or you could do 0.095. Oh, sorry, no. 0.975 times 400, either way. And that would equal 390 patients. Okay? Alright. Now, example 4. The distribution of delivery times for pizzas made by House of Pizza is approximately normal. So normal meaning normally distributed, with a mean of 25 minutes and a standard deviation of 5 minutes. So straight away I'm going to draw my curve. Okay, it's going to be dodgy, but it will do. There's my mean. My mean is 25 minutes. I've got 1 standard deviation, 2 standard deviations, and 3 standard deviations. Okay, so 1, 2, 3, 1, 2, and 3. Okay, and it's a standard deviation of 5 minutes. So that's 30, 35, 40, 20, 15, and 10. Okay. What percentage of pizzas have a delivery time of between 15 and 35 minutes? So 15 to 35, well, that's within 2 standard deviations, so therefore that one is just 95%. Part B, what percentage of pizzas have delivery times of greater than 30 minutes? So greater than 30 minutes is this onwards, including the little bits that hang out. So that'll be 100% minus I don't know if I misread that. What does it say? What percentage of pizza have delivery time of greater than 30 minutes? You know, that's right. Okay, so it's 100 minus the 50% plus this little bit here, which is 34. So 34%. So taking all of that away. Okay, so that's 84. So it should be 16%. Okay. Yep. Now C, In 1 month, House of Pizzas delivers 2,000 pizzas. How many of these pizzas are delivered in less than 10 minutes? Less than 10 minutes is all of this. Oh, sorry, I don't know why I'm using black. That would be what's here. So outside of the 3 standard deviations. Now, that's really hard for me to work out. So what I'm going to do is I'm going to work out both of them, and then I just want one. Okay, so that's going to be 100% of the data, all of my data, including that, minus 99.7. That'll give me both those little leftover bits. Okay, and then if I divide that answer by 2, it'll give me 0.3%. And that's how much data is outside of that. Oh, sorry, not 0.3, I forgot to halve it. 0.15%. Okay, now to find that how many of 2,000 pizzas, it's 0.15 times, it's 0.15% times 2,000, or you could do 0.0015, because you've got to divide that by 100. Even though it's a decimal of a percentage, it just means part of it 1%. So you can't just, you still have to divide by 100. Divide that by 2,000 and you'll work out that it's only 3 pizzas. Okay. So that may be a little bit confusing the first time hearing it. Have a look at those examples very carefully. Make sure you draw a bell curve for every question that requires it. Okay, so if it's telling you about how the data is distributed, it makes it a lot easier if you record it down and colour over it, scribble over it, whatever you need to.